Hey guys, so today we are starting chapter 6, section 1 is where we're going to start about graphing lines. So we already kind of know what graphing is, but our objective today is we want to recognize key characteristics of a function that can quickly determine the shape and location of its graph. So instead of having to plot 6 or 7 points to get an idea of what the graph looks like, we're going to be able to look at a function and determine the shape of the graph and the location of the graph just by looking at the function rule. So it'll be really neat. The first thing I want to talk to you about is linear functions, okay? Linear functions are a special type of functions that can either look like this or this. Okay, so remember f of x is the same as saying y. Okay, so these are called linear functions or linear equations. And the reason that they're called that is because all the points that satisfy them form a straight line. So when you have a function in the form of this, you're going to end up with a straight line when you graph it. What we were graphing was this: y is equal to x plus 5. And this, remember, is an example of a linear function, So we'll go through all of that again so I can get to the next slide. We plotted the points. There we go. All right, moving on. Now we're going to talk about the standard form of a linear function. So this is what is the standard form for a linear function. Looks like this. You have ax plus by equals c. So that a and that b and that c, those are going to be numbers. Like they could be any numbers. A could be 1, b could be 3, c could be 23. They could be any numbers. The only things that will not be numbers, of course, will be the x and the y. So this is standard form. Okay, so the couple of things you need to notice about standard form. The x and the y are both on the left-hand side, where the constant, or the number that does not have a variable with it, is on the right-hand side, right? So several different standard form equations are possible for the same linear function. Right? Another thing about the standard form is that it usually does not have a fraction, okay? If it has a fraction, you're going to multiply every term by that denominator to clear the denominator, and that way a, b, and c become integers, right? They will no longer be fractions because you're going to multiply each term by the denominator to get rid of the denominator. All right. Also, a should be a non-negative number. So remember, a is what comes in front of x. So x, when it's over on the left-hand side, if it's negative, you have to take care of that by dividing every single term by -1, and that way that will clear your negative. And so your a value will be positive again. So let's say I have this linear function. F of x equals -5/7x plus 2. Okay? And I want to put that in standard form. Okay? First of all, I have to realize that f of x just really means y. Right? So I have an x and I have a y. So now I can get it to make it look like ax plus by equals c. Remember, that's the goal. So the first thing I want to do is I want to get x and y on the both sides. So now, currently, I have -5/7 x on the left-hand side. So I'm going to add 5/7 x to both sides, so that way it clears it from the right-hand side, right? I'm going to add 5/7 x on both sides, and I am with 5/7 x plus y equals 2, okay? This almost looks perfect, except for, remember, I told you cannot have fractions, so we're going to multiply each and every term by 7 to clear the denominator, because when we multiply 5/7 by 7, the 7's cancel out, leaving us just 5. But we also have to multiply 7 by y and 7 by 2, giving us 5x, because the 7 canceled, plus 7y plus 14. All right, new example. Let's say we need to graph x plus 3y equals 4. So when we were graphing, we always had y is equal to, right? So we could find our ordered pair. So this is where we are going to have to solve for y first before we can plug in values, right? So in order to solve for y, you have to solve for y. Okay, so this is a two-step equation. Okay, two-step equation, which means we take care of the addition and subtraction first. So 3y is currently has a plus x on it, which means I'm going to subtract x from both sides, right? So now I've got 3y is equal to negative x, that's my subtract x, plus the 4, okay? Your x always wants to be at the front. You wouldn't put 4 minus x. It would be negative x plus 4. It's the same thing, but because we're talking about linear functions, there's a certain way we write it. We always want to write the x term first, okay? So now, to solve for y, we're going to divide everything by 3. Because when we divide 3y by 3, it leaves us just y, which is what we want. And that means we have to divide x by 3, and we also have to divide 4 by 3. And we can just leave it just like that. Now, this is a function rule, which means that we can create our table and plug in x values, get y values, get ordered pairs, and then we can plot those. Not show, nope, it's not going to show it, but we would graph it, right, on the coordinate plane, graph those points and connect the dots. All right, now I want to go over with you the steps of graphing a linear equation. Step 1, solve the linear equation for y. Okay, so it'll probably be in standard form, ax plus by equals c, and you have to solve for y in order to graph the linear equation. Okay, step 2, you're going to make a table of at least 3 ordered pairs using convenient values for x, right? Use values for x that are not difficult to calculate. Okay, step 3, graph the ordered pairs that you calculated on the Cartesian plane. Step 4, connect the points with a straight line. All right, let's review some definitions. We're going to learn what intercepts are, okay? The y-intercept is the point where the graph intersects the y-axis. Remember, the y-axis is going up and down. So the y-intercept is where your graph intersects that axis, where it crosses, where it touches, okay? The x-intercept is the point where the graph intersects the x-axis. Remember, the x-axis is horizontal, so it's where your graph is intersecting the x-axis. All right, so it's really easy to find intercepts, okay? A line's intercepts can be found from the equation without graphing, okay? And the long way would be to graph the function, look at the graph, and find where it's crossing the x-axis and the y-axis. And that could take a really long time. There is an easier way to do it, okay? The y-intercept always has 0 for its x-coordinate. Because if you think about it, you're looking for where it's crossing the y-axis, and the y-axis has an x-coordinate of 0 because it's at the origin, right? X-coordinate of 0. So the y-intercept always has a 0 for its x-coordinate, and vice versa. The x-intercept always has a 0 for its y-coordinate, okay? We can find our intercepts very easily. So let's say we have this linear function, 2x plus y equals 6, okay? If we wanted to find our intercepts normally using the graph, we would have to solve for y, pick some x values, find the ordered pairs, plot them, connect the graph, and then see where they're crossing the x-axis and the y-axis. Or to find the x-intercept, we're going to substitute 0 for y, because remember, the x-intercept has a 0 for the y-coordinate. So we're going to let y be 0 and then solve for x. Well, if y is 0, that means we have 2x plus 0 equals 6, which means that x is equal to 3. Awesome. All right. If we want to find the y-intercept, we're going to let x be 0 since for the y-intercept, the x-coordinate is 0, okay? So we're going to let x be 0 and solve for y. So again, x is going to be 0.